Okay, now in this video, let's try and understand how to make a light control plugin. Basically, we'll making a light control plugin will make a disco light effect on Gazebo Sim. Okay, so let's understand how to do that. So these are the two lights that I'm going to use for making the disco light effect. So if you go on the slides, basically we'll be changing light colors on runtime. Okay, so if you go on the slide, you'll see there are these two spotlights that I'm going to use. So if you go on this light, you will see this light is an component. Okay, so when you go inside this component, there are these two specular and diffusion that helps you to change this color. So what are we going to do is we are going to just change the diffusion and that color, and once we change these colors, now the light color will get changed. Majorly is diffuse that we have to change to make the light color change in Gazebo. Okay, so these are different properties of a light control that's loaded from this SDF file when you go inside. So these are all the light control properties that being loaded from there. So in this video we are going to make a light control plugin that's basically a system plugin, the another system plugin that we are going to write, but we'll be writing this in the ROS workspace itself. Although this is a standalone plugin, but generally we are going to use with ROS. So I want you to also write some plugins that is purely ROS, purely Gazebo, but we can still write it in ROS to workspace. Okay, so now this is how we are going to change the light, and the specular and diffuse is the two parameter that we are going to play around to make that disco light effect. Okay, so let's go back to the documentation. Here you can see these are the two lights that we are going to play, and what is the logic. So as I told you, this is a component and this is the two parameter that we are going to play around. So what are we going to do? We are first going to read these two light values, the current values, the all the values those are mentioned within the light component, and we are just going to change the value for this two, specular and diffuse. These are the two parameters. This related to color, we are going to just change those two parameters. Okay, and every iteration we are going to change on runtime. We are going to change this on every cycle of the plugin runs. We are on each loop we are going to change this color so that we are going to get that lighting effect of disco. Okay, so how the color change logic works. So if you see the code over here, it is using a sine function that looks like this, and let me show you in the graph. I've already opened the graph over here. So if I turn on this red, so this is just a normal graph that oscillates between 0 and 1. That so 0 means it you will have no color, 1 will you will have a dark red color. So there are three RGB values of each color, if you know. So each of this has this RGB value. So there are RGB values for each of this. So red, green, blue. So new color always has this RGB value. So we are going to set it up using this. So this is one color. Now if you see the second one, the green one has added up a offset. So basically this is a phase that we have added onto this. So it is not going to start from here. It will somewhere start from some other place. So what will happen, because this all are starting from different areas, every time it's going to create a different color. If you see the interaction point over here, it is a different color. If you see the interaction point over here, it's a different color. If you see interaction point over here, it's a different color. Okay, same goes with blue as well. So combination of these three is going to every time gives us a different colors. So this logic is more for changing colors on runtime. Every time dependent it changes. So on this, if you see, I've mentioned this time. For x-axis, I've taken as x as the time. So here that time is there, and that's how we change the color. Now the main thing we have here are two multiple entities, not just one. So if you remember on the videos, the common plugin that we know, all the videos that we have seen till now, we discussed this two method of finding the entity. One is this. One was this when directly entities are attached, then we use config to get the entity, and the other was by searching name entity by component. And then how are we going to read this up? By name we used to search, but now how are we going to do it for multiple entities? So we are going to use, there is something called each. So each is part of entity component manager. I hope you already understood this entity component manager. We have been using this a lot on the code. If I show you, So entity component manager is the one that's defined on pre-updates. This entity component manager, this is a part of interface. So this, it is what controls entity component system. It manages both entity and the component. I hope we have discussed this all right. So this same is we are going to use for this, and if you see each, so it gets you all the entity which you based on the component type. So let's go back to the code over here. Yep. So if you read this code, what is actually each is doing is looking for all the component that has light and that has name, that has light and that has names. So only those two component. If you see over here, so if I see any of the entity, it definitely has, if I minimize this, it has this name component and it has this light component. So this is going to get detected. So what is the other component? This lights, another light spot, it has name and light component, both is there. So ground doesn't have light component, neither default has light component, so they're not going to detect. So this is how each gets you based on the component. It can get you multiple entities at a time. So it sort of has a callback function that I'm using a lambda for here. No need to go into so much of detail. It's just that remember the syntax how it is done. So here we are trying to find this entity. It is going to return the entity based on, it is going to return the entity, light and the name. Three of this, but I've put star, that means I'm not going to use from here. So we are using this entity. Okay, so this entity value we're pushing into light entities. So this is a list of entities. If you see .h file, this is a vector and list of entities. So if even if this logic is going to even work if we have 3 or 4 lights. So this is how you can get multiple entity at a time. Okay, so now if I want to print it, then we can use this name to print over here. Otherwise you can star, you do not need to, you won't get any values. So this is just a callback function that gets you all the 3 values. So each is very helpful for getting you multiple entities at a time. Okay, now once we get the entity, we have to update the component. How will update? So every time we start writing any system plugin, this is the main page that we should always come onto this page, and we should see what are the component related to those are there on our use case. So for example, if I search for light, you will get this 3 that are useful for our light use case. So this is light, then light command and light type. So if you remember, we discussed this, if anything written cmd at behind of it, that means that it is for sending a command. So that means it is for writing on the light. Okay, so we are going to use that to make it right, but here is a catch. See, so this to have a different data set, this is an sdf light. The light is an sdf light, but on for writing we need to get it to gazebo messages light. So now we need to do message conversion over here. How we do that, let's see. So on this, back on this our code, so as I already told you, this component light has sdf light. So sdf light is loaded from .sdf file where the light is attached, and this one is basically gazebo light messages. Now we are going to use conversion. How we use this conversion? If you go back to this Gazebo Sim, so you will find this conversions a lot. What? So you'll find a lot of this conversion over here. So one that we are using in our code base is a conversion for standard lights, because we want to convert we want to convert the SDF light to a whichever template we mention over here. So what are we going to mention? We're going to mention this GZ message light to get it in this format so that we can make a light command from. So what are we doing? We are reading the light and then making it for light command. That's where we are converting this message to this gazebo messages. Okay, SDF to gazebo messages. So this converter helps us. It takes the SDF and gives out gazebo messages, anything that you mention in the template. So this is wonderful use case of this conversion, helps you a lot. So you can go into APIs and read about other conversion as well, but as we are using this, we'll be reading about this only. Now once your conversion is done, now your message is in gazebo's messages light format. Now if I open this as well, this API doc, so there are different parameters of it. So basically these are all the parameters related to this light that you can play around. Okay, so these are different material. For us the important one is mutable diffuse. Mutable in the sense that you can change the value of it. Same goes with mutable specular. So these two are the color related parameter, right? We just discussed this. These two are the color related parameter. We need to change their values to send it to command. Okay, now how we do it? And the important thing over here, if you see, both of them are gazebo messages color. So both data type of both are color, gazebo message color. So both are of gazebo message color. Then there are many set function that's also there on the same here. On this, if you go on set, on the Gazebo Sim itself, you'll find a lot of the things that you look for. So on set, you'll find a lot of sends. These are user defined functions. So you can find those over there. I've mentioned for our use case. So our message that we want to use is mentioned over here. So the important thing to remember on this is that this message attribute, it can change one value at a time. That's why we have to write message mutable. First value is color of diffuse, then specular color. So it can change one parameter at a time. One parameter at a time. What I mean by that is color messages. Okay, this is the color messages. It has many other attributes like intensity and others. We are just looking into the color one. Color one, we have this diffusion, and then we have this specular. Okay, so these two values, so basically this message is there, then this set can only change one message type at a time. So both of them are of type color. So at a time we are changing this message, then at a time we are changing this color message. So we are changing one by one because this set can only change one parameter of the message, not the entire message. It can't change this entire message. It can just change one value of the message. That's why we are doing 2 times to set the new color. Okay, so I hope this is also clear. Yeah, everything written over here I have explained. Now our message is ready. We firstly read our entire message from write, then we convert it into light command. Now we converted it into a message that support light command, that is this message msg. Now we have to send it to this light command. How we do that? We know this from move model plugin, right? So we do it the same with the two method that you can use component to update the message. If the component doesn't exist, it creates it and then sends the message. The other ways, the simpler one is just set component data of ECM. So we set this component data, and on this we are setting the light command, that we just talked about, and we are setting the message value. So we are setting this message values, and this takes and everything is same. It's the same thing that we are doing for setting that we discuss in move model plugin. So same way we exactly samely set it up. Now another important thing over here is what happens in the case of light is, so for the case of model, the model velocity was updated by physics. So because it was physics, it is keeps on updating by itself. The component of this velocity was getting updated by itself, but in our case it is just a light. Okay, so we need to give it to rendering. So until we inform rendering that this light has been updated, it's not going to update. So for doing that, we have to use this set change, so that now the light component knows that the speculation and the color component, the diffuse and speculation, the both color component, both are being changed. Those values are being changed. Now you have to update this light color. So for informing that, we use that set changed. Okay, so we use the set change, and what it takes the entity first, is the entity, and it takes the type. So this is the light command type. We are saying this light command value has changed. Basically we are changing the command, and then we are how it has to be changed. We are saying that change it periodically. So it's okay, that means it's okay if we are dropping some samples, but mostly we want you to change. So that's That was the use case of one-time update change. And there are some more another method. If you go on to the API, you can look into it. But we are using this periodic change so that it's okay if few samples are being lost on the process. If few samples are lost, also we are okay with that. Okay. Now let me show you the whole code so that you can understand it better. First, let's see the SDF file. I have to first uncomment this SDF file. I've uncommented this SDF file. Now we are not setting up any tags over here. We are not setting any parameters within this SDF file. Okay, and this is registered on the part of world. Because it's a part of world, we wanted to read two models. So that's why we are not attaching it to any of the models. We are attaching it to the world plugin. Okay, now let's go to the code. Code is very simple. So on the H file, we are just mentioning some entities, vectors that we want to store all the entities of light that's there. Then we are using pre-update because we want to read and write both, and this light control is normal. And then we have mentioned some of the include file that's needed for it. For example, we need name, we need light, we need color, and we need light as well. And the some of them are also mentioned in .cc file. So it's fine even if you mention a .h file, even if you mention a .cc file, it's fine. It's not a big problem. Then there is namespace. Then we are using this find entity to find the list of all the entities. So what happens, let's see from pre-update. So what happens when pre-update starts, we say if we are paused, then just return. If we are not paused, then just update our time based on the standard chroma duration. This is just for getting the latest simulation time. Okay, so using this, then we ask him to find the list of entities. What happened when it comes to this entities, we give it ECM, entity component manager, so that it can calculate the list. We give the ACM so that it can use this function of each. So firstly we clear the entity list, that every entity list on every iteration we clear it. We say that the list is empty. Now check for what are the new light on there on your list. So every iteration it clears it first. Then the each we already discussed. Then it gets it at the end, it gets the list of entity for this vector that we have defined over here. So we store all the light entities on our vector. Now once the light entities and added, if the light entity is empty, that means there is no light on the scene. So obviously we will not run the plugin. That's why it returns. But if there is light entity, then it's going to go forward, and then we use this animation to change our color that we just discussed. And we'll also discuss about the flickering, but let's first see the basic stuffs. Okay, now from this entity, the light entities, we run a for loop to run on each entity. Like we have entity number 0, we have entity number 2. It is going to run on all the entities, right? So now we use the same that we just read to read the data from light, and then we convert, and then we set it up all for each entity we are doing every time. Okay, now we set this command to send this message to light command, and it updates the light color. Okay, and then we register the change, and this plugin is done. So this is what it is. Now let's build the code once again, although I've kept it built, but it's okay. Source, already sources source to launch. We are using light control normal, and we launch our plugin. Now you will see this light color getting changed on the runtime. See, this light colors are getting changed. So these colors are gradually changing on the runtime. And the interesting thing is, I can show you the component, what is happening. It's the light command is changing so fast because it's getting every iteration, right? So as we just talked about, every iteration periodically we are updating is fast. So every iteration a different light color is being registered, and that's being updated, and that's why it runs so fast. If you open this read of the light, you will see this color getting changes. So this color getting changes, this green gets changed. So that means we are using light count, we're changing the light component. Okay, and it's able to iterate on different color and still it's not giving the disco effect, right? We'll make it happen in just a moment. Same goes with the other light as well. It's same thing exactly happening over here. Now let's add the disco effect. Before I add the disco effect, understand this. So on this disco effect, let's comment this out and let's uncomment this entire part. Nothing special is there on this. So it just use this pi sign. It's a normal big function. The actual use case, it just iterate the oscillate on different frequency. Let me show the graph, then you'll understand it better. So that is the graph of it. So if you have this some values added onto the graph, it is also a sine function, but this sine function, if you see, this is like this, it oscillates on value. So that means the intensity is constantly getting changed. Because the intensity is constantly getting changed, you are getting the disco effect. Okay, so this is half of this, and now if you add 3-4 sine graphs, that that becomes more dense. Now you get a better disco effect of, even the size of this is varying, right? So it varies on this. Now we set a cap on this. I'm saying that it you have to be between 0.15 to 1.0. Okay, so that we are able to see the disco effect. It doesn't happen that it goes to light 0 and then it takes some time to come back. That's why this cap is there. Now everything that we are changing is same, just we multiplying this flickering effect so that the intensity of RGB is going up and down and we'll get that light effect. Okay, as well as now we let's change one more thing on this. What is on the light? Let's make it point 4, the inner circle. So inner circle, what is the meaning of inner circle? So basically, if you know how gazebo light works, it's interesting. If this is an outer circle and this is an inner circle, these are the two circles on which the entire lighting thing is being done. So I'm trying to increase those to bigger sizes. Okay, sorry for the drawing. I'm trying to increase those to bigger sizes so that both you and I become bigger and we are able to make it cover entire big surface and we'll see the lighting effect. Okay, so I've increased this inner surface. Let's make this outer as well to 0.2. I've already tested with these values I mentioned on the corners. Same way, let's make it 0.4 and let's make this to 2. Okay, now we'll get a crazy disco light effect and gazebos. Let build it because we have changed on C file and we are building our code again. Now let's launch the same code. Did we not change the light? Oh, we didn't change the outer circle for this. My bad. Sorry. So we changed the outer circle. Now let's relaunch this. We changed both inner circle and outer circle of this. Okay, how? Still it doesn't look good, right? Because this area is light is on this area. Let's entirely switch off the light, then we'll see the magic happen. This is just making it look cool. I'm just doing it to just show you. It's nothing special about this. Now we'll activate the scene ambition and background so that the white background of the room becomes dark. Now see this. Now this looks like a diesel light on Gazebo Sim. So this flickering effect is also added up and your light is also getting changed. This looks beautiful, right? Yeah. So we are able to make a disco light in Gazebo Sim. This is how, if you know how to play with custom plugins, how to use your own component, how to use entity component system, ECM, entity components manager, and all those things, then you can make a lot of crazy things in Gazebo Sim. You can code crazy things in Gazebo Sim. Okay. Okay. Now one more thing that I want to talk about is there is one more way that we can use for making light work. So there is third method that we could have used using the light class. If you remember, we also had the model class. If you go back on Gazebo Sim, this has this light class. So this light class is wrapper around the ECM, but the problem with this class is, for our case, it would be a problem. Why? Because if you go down, so the syntax of this light class is simple, that you just add your entity and then you use set diffuse color, set specular color, ECM, and new color, you can set it up. But the problem with this set diffusion color itself, and let's open the Gazebo Sim API and we see on the code what is the problem. It's not a problem. I think it's written considering some other factor, but if you use it for your case, it would be a problem. Why? Because, so what is this diffusion? Okay, let's search for diffusion. So if you see this diffusion code over here, the exactly same code I was talking about, this is Gazebo Sim repository. SRC, within SRC, we're looking at light.cpp file. Even you will find other definition codes over here. But now this uses the same light command component, and then the problem here, it makes a new light messages. But in our case, what we needed is we wanted it to convert the readed messages, because we do not want to change others value, right? Other value in the sense, so there are so many others values on this, right? If you see this, not just one or two values are there, light has got many other component as well. We are just playing around this two values, but not, we are not changing any of this value. It is, for example, the range is mentioned 4. So this is directly getting copied from this light tag over here. Range is 4. See, range is 4. So this is directly getting copied from here, and we are just changing the color. But on this code, this entire line means that you are going to basically make a new light message, and every other value is going to get 0, and the color that you enter is only going to be added up. Now that will make other value 0, and you won't see your light happening. So first time when I was coding this, I used this to understand, does it works? Then we'd have two method or it doesn't. So let's change the code and we'll see why it doesn't work. So let's comment everything out from here. We do not need this, any of this. We just need this entity to be here. We do not need this as well. And we just uncomment this. Then this sets up the light, and this is there. Now you'll see your plugin stop working. We'll build it because we change in this .cc file. We'll build our code. Nothing is getting changed. Why? For the same reason that I told you. If you go on the light, you will see every intensity, every other values converted to 0. Even if you try to manually make it 1, it won't. Why? Because if you just go on to something and if you come back, your value will get back to 0. So the problem is that this API, this all other values are converted to 0. Because of that, even the diffusion is getting changed. We are not able to see the color, and specular is not even getting changed. Diffuse is getting changed and specular is not getting changed. Why? Because every time this code runs, the entire code, it creates a new messages, and every other values get zeroed. So my point is, you should be very, very careful if you use this template of this light or model or some things, because those may not give you the right thing that you want to do with your code. Reason being, they have been coded with the limited ideas, and which may not be suitable for your code base. So you should always use the entity component method. The entity component method that we discussed, you should always use this entire entity component method. You should never touch those light, model, all those things, those wrapper classes that are there. So even that's there for model, you'll find it for many others. Model is there, if it, you will find it for link. I mean, sometimes it could be useful, that's why I talked about it, but sometimes it could be very, very unuseful, and it can make your code worse, and you'll be just hang on debugging issue. What is the issue? You won't be able to get it up. So it's better that you never use these methods. Rather, you always use the entire ECM method, entity component manager method, that's handle everything for us, right? So my idea would be, you should always avoid those wrapper classes. Use entity component manager for all your use cases. It is back and working perfectly fine.